to be exact, with hot molten glass. As today's demonstration begins, again, my name is David. I'll be more than happy to answer any question you may have about the demonstration. I am also more than happy to share my own glass experience. Before we begin, I do want to let everyone know that we offer complimentary water. When you enter the museum, on your right-hand side of the hot shop, we have a water station. Please feel free to grab some at any given time. It's very important that we all stay hydrated. A great place to view the live glass making is also out in our grand hall. We have a live stream set up out there. It's a great place to kind of watch the live glass making in a cooler environment. With that said, you can notice we're already jumping into the hot glass action itself. I do want to introduce our two visiting artists here today, starting off with Phirak down here. Now, he's already jumping into the action. Notice he's already setting up the 3D printer. Here in a few minutes, we're going to begin the 3D printing process. Everything we print here today, right now, will be used tomorrow. We are using and creating these vessels you see on this end. So everything you see here will be used tomorrow. We will blow inside of them. These molds are only temporary, so we will break free the ceramic. It's only going to stick on the glass to give us the initial shape. We then have our second visiting artist here today, working down in the center of the hot shop floor. Now, throughout the demonstration, I'll let you know about our visiting artists, who they are, where they're coming from, and all that good stuff. But again, two visiting artists, a collab essentially is happening today. We have Brandyn Callahan working down here in the center. Now, Brandyn is the person in charge of the hot glass, and you'll notice that he will take a seat down in the center of the hot shop. We call this the gaffer's bench. Person sitting in the center is in charge of creating the pieces we make here today. With that said, we also have a separate project going on the right-hand side of the hot shop floor. If we take a close inspection of the pieces we create on our pedestal, we notice this looping effect, this kind of texture. We're going to replicate that here in glass using these long strands of glass that we will pull out. They will be used later for a sculpture. Now that we have a basic understanding of what's being created here today, I'm going to let you know about the hot molten glass itself. It is all coming out of our furnace we have on your left-hand side of the hot shop floor. Sitting here at the museum, our 1,000-pound furnace is always melting glass. Sitting behind the door lies a crucible. A hot pot of glass is being heated up to 2,100 degrees, so it's extremely, extremely hot. Now, once the glass exits the furnace, it begins to immediately cool down. We then use a reheating chamber, a glory holder, to heat up the massive glass. We see our visiting artist, Brandyn, down here, distorting the very color on the surface. Earlier in the process, we added a decorative wrap. This wrap is this white piece of glass you see on the very surface. Initially, these are wrap that we add is straight horizontal. We do want to give it a more of a distorted look. So we will then roll on a steel table or a texture plate. As we see here on the hot shop floor, our visiting artist, Brandyn Callahan, is getting that hot layer hot and then distorting it when it comes time. By letting the core cool down, we're doing a handful of different things, both essentially ensuring that we can manipulate that massive glass, but give us a longer working time. Hello, welcome to the museum. Thank you for joining us. Hope you're having a wonderful day today. So the striping begins early in the process. We just saw that earlier where we came over to a little kind of a decorative machine, which is this one down here. And we brought over a white wrap of glass, white color, placed it on here, and we saw that process. Later on, we'll also kind of show you a replay of that action so we can understand exactly how that stripe was added in the glass. For my audience down here, however, you're seeing a very good view of this 3D printed ceramic we're using. Now, this is different ceramic than your average ceramic you may have at home or experience with. Now, this is flameware. It's specifically made to resist the high heat of glass. Most glass will just, or most ceramic will just crack when it meets the hot glass. That's due to its COE. Its contraction and expansion rate will be different. Now, glass, when it's cooling down, is less than 1%. It's not really noticeable. However, ceramic shrinks more than 15%, which can act like a snake and really constrict our glass and cause it to break and crack. This specific ceramic, however, won't shrink too much, and it shouldn't cause the glass to break itself. But again, we won't truly know until tomorrow once we bring the pieces out. The clay that we're using down here for our 3D printer, this is just your average clay. There's nothing special about this. This one, the reason we can use a real general form is that they will only be temporary, which means we will only use them for a short while. So we have our visiting artist, Brandyn, down here, rolling back and forth on the steel table. We call this movement marvering the glass, shaping it back and forth. Now that steel table will suck the heat out of the glass and give us the designated shape we may want. Traditionally, these tables were made out of a solid slab of marble, and that's where we get that name marver from. However, nowadays it's been flipped with this steel table, which does a very similar movement without actually cracking a slab of marble, but a very similar movement of heat. Now, for my wonderful audience, again, I hope everyone's having a wonderful Monday afternoon, especially since you're spending it here at the Museum of Glass. Again, we do offer water for all our visitors. It's on the entrance on your right-hand side. It's very important that we all stay hydrated here in this hot shop floor. We can see that glass blowing is all about teamwork down here on this hot shop floor. We're standing by to blow air through the blowpipe. When we're blowing air, we're typically blowing about the same air pressure you use to blow out a candle. So it's not a lot of air, but it does vary. Sometimes we're asked to blow very softly, and sometimes we're asked to blow hard. It really depends on how much we want to expand the given bubble. Notice there is a hierarchy going on here in the hot shop floor. Our featured artist is down here working in the center, called the gaffer. We then have the pole turner. In this case, we have Taylor Ames, another professional glassmaker here. His job is to give the adequate heat that the gaffer has asked for. One of the trickiest moves is this move we're seeing here, creating a weak spot or a break-off zone in the glass, a small constriction that we can later use to break our piece free. Now, one of the shaping tools we use here in this hot shop floor is a wet padded newspaper. As long as the newspaper is wet, it shouldn't catch on fire or leave any debris. Here at the museum, we do have a preferred newspaper. We do burn the Wall Street Journal, but any old newspaper will do. It only lasts a few days, but it's totally fine. We'll go ahead and recycle that pair and fold a new one. The mold that we're going to be using, or the ceramic piece specifically, is sitting down here on the table that we have all our tools laying out. We're going to ensure that our shape is the right size and the height before we attach the ceramic portion. Now, the rods that we use here on the hot shop floor, they're made out of stainless steel, which is a very poor conductor of heat. So the heat itself is not being transferred all the way through the rod. As you take a close inspection of the rod, you can begin to see the distortion happening to the rod itself. Towards the tip, it becomes dull gray and black. Now, we actually don't place our hand in that darkened area zone. Rather, it's directly behind that, where the rod is still a little bit more cooler. If the heat does build up, we will then just use some plain old water to cool the rod down sufficiently. Do we have any questions from the audience? Any questions that you may have about the process you're seeing now? One great place I do recommend watching the live glass making is the top balcony. It's a great place to take any pictures or videos of the action going on, but most importantly, you can hear the communication going on between the team. Well, now that we've applied our ceramic piece of glass, the glass blowing can resume. Now, we are going to ensure that that ceramic portion can stick to the glass. It's really due to the texture on the inside and the compressed air that we've created to ensure that that ceramic portion does not slip off the glass. Now, again, the ceramic is specifically made for hot glass to ensure that it doesn't crack when they meet one another. All the wooden tools we use here in the hot shop floor, they're made out of fruit wood. We prefer to burn fruit wood because it contains more moisture than any other typical type of wood, which just give them a longer lifespan. Now for this move, notice we're doing a variety of different things. We are blowing through that blowpipe, but we're also just placing our finger over the hole. When we're squishing the bubble in any form, like using the wooden paddle to create a flat bottom, we can also deflate our bubble. To ensure that we have a nice shape and it doesn't collapse, we place our finger over the hole whenever we're squishing the bubble itself. Now that we've created the flat bottom, the next step is to move on to a different transfer. We're gonna put this piece on a different rod itself. So we're gonna bring over what we call a punty, which is the transfer rod. You can definitely feel some of the heat up here. That torch is definitely some heat. Well, the torch that we're using now is a propane torch. It's about 2,500 degrees Fahrenheit. We use it to heat up one specific area of our piece to ensure that that spot will stay warm enough to continue to be manipulated. Using a tungsten drill bit, we will drill a hole towards the very bottom of our vessel. This will give us the ability to blow air through our piece even after this transfer, so the glass blowing can continue. Now down on the left-hand side of the hot shop floor, we have Isaac, who's standing in front of the furnace. He's getting ready to gather another layer of hot glass. With that hot glass that he has, he will manipulate to the new handle. When we bring over a handle, remember, it will only be temporary, which means it needs to be strong enough to withhold any pulling or tugging that we might do, but also weak enough to break when it's time for the piece to be broken free. So as we keep it nice and warm, we're preparing for the break-off, the transfer that'll occur here shortly. So everything you see on our top screen, we live stream HD, of course. It's now a necessity. So we live stream everything you see on the top screen, both through our YouTube channel and also our own website. Our visiting artist down here today is both, where do we see Phirak? Oh, Phirak's down here now. Phirak is designing all the pieces that you see being printed out here. And our second visiting artist is down here creating the actual vessel. So this is a collab between both our visiting artists. What you're seeing here is a lot of experimentation, just because ceramic and glass don't really mix well. They tend to break. But here today, we're specifically using this ceramic that's made for this type of heat. The pieces shouldn't break, or they should at least minimize the pieces that we break. Here we're using wooden paddles to shape or to shield our gaffer from the heat that the glass is radiating off. Remember, when it's exiting this chamber, it can be upwards of 2,000 degrees Fahrenheit, hot enough to burn. So we use the wooden paddles to shield our gaffer from any heat that might be radiating off. Now, this museum has a very iconic design. This cone steel structure is very, first of all, it's a very functional glass blowing studio. Around the 19th century, there was studios built in this kind of cone-shaped design, especially all around Europe. Now, the reason we have really this cone at this size, however, is due to Tacoma's early history. At one point, Tacoma was called the capital of the lumber industry, with well over 70 lumber mills just in our area. Due to that large lumber industry, they used to burn a lot of excess wood in what's called a wigwam burner, which looks very similar to this cone. The closest wigwam burner in our area is located in Aberdeen, Washington, but they look very similar to this cone-shaped structure we have here. Although it creates a natural chimney where hot air can rise. On the top here, to speed up the ventilation, we have a fan that just sucks away the hot air. All right, so we did see a piece being completed on the right-hand side. What we're making down on this right-hand side, again, is this loopiness effect, right? When we're done creating a piece, the next step is to slowly cool it down. So any glass that we make here today, even the vessel, will be going off into the annealer. So it's the black oven with the green number 1. It is currently sitting at 920 degrees, and it will be the home of anything we create here today. Unfortunately, if we leave glass out here, it'll get too cold too fast. It can break, crack, and even explode. So to prevent it from breaking, we will slowly cool it down. Yes, slowly. It really depends on the thickness of the glass. It can vary how long it stays in that oven. For our pieces, around 24 hours should just do the trick. Any glass that ends up on this ground is recycled. It's thrown away. Unfortunately, we can't reuse it here at this museum, specifically because it contains color. If we try to remelt it in our furnace, that color can spread throughout the clear glass. Even if it's clear glass that's on the ground, we can't recycle it due to its dirt and debris content that it might have picked up on the ground. I believe the glass that's recycled here goes off to be used as road filler. Yes, every single ceramic piece you see here will have its own blown glass with it. The ceramic will stick with the glass, of course. We can create different like light fixtures and decorative elements. So the pieces that we're 3D printing here today will be used for tomorrow's demonstration. So everything you see there will be used tomorrow. Glass, the way that glass will be incorporated with these is these are going to dry for a little longer. We will then blow inside of them. Since they are hollow, we will blow inside of them and get that shape. Once it's cooled down, we're just going to break the ceramic free. That ceramic will only be used for about a minute or two before the glass cools. Yep, the glass will take the shapes of the vessels we have there on that table. The vessel that we just saw in the center is now complete. It got broken off and set it off into the annealer where it will cool down for the next several hours. And just like that, we have completed the first piece of today's afternoon live glass making demonstration. We are going to continue the fun down here, so if you didn't get to see the beginning part, the crew is already jumping right back into it. We're going to see the coloring application process. This time we'll explain everything start to finish so we can all understand how this piece came to be. However, the color themselves are made separately. We always have to apply it differently, and the solid color comes to us in a bar form. This is what we're buying from our manufacturer. Colors typically made outside the United States, out in Germany, New Zealand, really just outside the States. The way that they make color is by adding different metals to the periodic table of elements. Different metals will produce a different color. So to create green glass, we might add chromium or iron. Blue glass, maybe some cobalt, lapis. Specifically different metals. To create red and pink glass, we use gold, which makes the red and pink some of the more expensive color in the glass industry, and it's due to that gold content. Now, depending on what we're making, we can use a full bar or we can just use a little bit. It really depends how dense you want the color layer to be. We see that the color has already been picked up down on the right-hand side. A glass maker has already gathered clear glass, stuck the solid color on top of that. The color needs to be preheated before we use it, so it's sitting inside the garage, a temporary place where we can store glass and keep it warm. Now that that color is being manipulated, we then have the start of our piece. Now this is the coloring application. We take clear glass and we create a bubble. So we're going to shape it by rolling back and forth on the steel table. Here very shortly, we're going to blow a small air bubble in our massive glass. Well, the process happening on this right-hand side, once again, those will be used later for a sculptural piece. So although they will cool down here, they will be used later on. Now, once again, my name is David. I hope everyone's having a wonderful afternoon. I'll be floating around the hot shop. If you have any questions, please feel free to stop me. More than happy to even share my own glass making experience. We have complimentary water here at the museum. We also have a great place where you can view the live glass blowing out in our grand hall. We have a lounge area. Remember that the glass is being kept in our 1,000-pound furnace, holding approximately about that same 1,000 pounds, about 2,100 degrees Fahrenheit. So it's extremely hot behind that door. It's like hot molten lava essentially there. Typically after the gather, we use a wooden block. In this case, we're ensuring that our bubble will blow out evenly by distributing both the heat and the massive glass around the bubble. Most woods that we use here in the hot shop are made out of fruit wood just because they have a longer lifespan and they contain more moisture. Well, we're now letting the core cool down, and by letting the core cool down, we're giving ourselves the ability to gather more glass, but most importantly, maintain more control over that hot layer we add. That cold core will really suck the heat out of the hot glass that we add, making our job of turning the rod easier. Now, although it just looks like clear glass, there is a colored layer, but the color that we're working with when exposed at this temperature will look clear. Now down on the right-hand side, we're getting ready to break our piece free. We have Bobby, a professional glassmaker on that right-hand side, that has suited up in a heat protective layer. He is now also wearing Kevlar gloves, the same thing firemen and women use to protect themselves against high temperature situations. Using that Kevlar, we will grab the piece and break it free. Now there is a variety of things going on. As we can see also in the center, we have gathered an additional layer of hot glass, but also breaking our piece free on that right-hand side. A great place to view this action is the top balcony. We also have some amazing artwork all made here at the museum. So this is just going to be used for a separate piece later on the day. You just kind of want to create the looping effect that you see in all our ceramic. Yep, that'll be passed later on the spot. So the pieces that we make on that right-hand side, they will be used for a separate piece, specifically a sculptural one that will happen later on. So we are just gearing up, prepping for that piece. The shaping pad we're using here is just wet newspaper used here to this hot shop floor. As long as we keep it moist enough, it shouldn't leave any residue behind or catch on fire. Similar to the last process, we use a wooden block to ensure that our massive glass will blow out evenly. Typically, this move is done after every gather. Now, the rods we use here are made out of stainless steel, again, a poor conductor of heat. But even with that poor conductor of heat, we still use some cold water that we run on the surface of the rod, which in turn cools it down. So the ceramic used in the 3D printer is just your average clay. The reason that we can just use our average clay is that it's not actually going to stick with the glass. We're only going to use it temporary to give us the mold, to give us the actual shape. So we will blow inside of each of these vessels we have sitting on the table. Within a minute or two, we will then break off the ceramic. All we want is the shape that it will produce. However, the pieces we see on this end, however, will stick with the actual glass. And this is specifically made clay for glass. If you're wondering how we apply the decorative wrap on the very outside of our vessel, that is going to be happening on the hot shop floor. We can take a good view of it on the top balcony or on the top screen. So when we bring over a hot, massive glass, this little contraption that we have here, as long as we turn, should pull the rod slowly back, creating a horizontal line effect. For this specific piece, however, when we have added this decorative line, we will go back and distort that line, ensuring that it's not a symmetrical look, but more of this distorted effect. For our audience that's sticking with us, again, my name is David. I am just going to be floating around the hot shop, talking individually. If you have any questions, I am more than happy to answer any questions. If I do lose you throughout the glass blowing process, please feel free to raise your hand also, and I'll be right on over and we can discuss glass blowing and all its fun characteristics. The distorting effect is happening now as we awkwardly turn that rod to give a different look. We will continue to repeat this step until we are happy with the distorted lines we create. By letting the surface cool down in the complete core, when we reheat the glass, it will only get the skin of the glass hot enough, and that's really what we want to disrupt. If we get the whole mass of glass really hot, we have a chance of distorting the bubble, which will cause it an uneven bubble. So by simply letting it cool down, we are ensuring we are only manipulating the very top layer. Well, we had an excellent question. The history of glass. Well, the term glass blowing and what we see now, typically it's agreed that it came around the height of the Roman Empire, around the, which is about 2,000 years ago, we could say. Now, what really transformed the glass blowing game, what we see here, is actually the blowpipe, which was invented around the height of the Roman Empire by Syrian craftsmen. They produced the first blowpipe. Now, to this day, we're unsure exactly what they used. It's believed they used copper tubing, but again, we're not entirely sure. We do know that Venetians, when they raided Constantinople, that they stole the glass blowing, and they took that back to Italy. Later on, Murano, Italy was really established as the home base of glass blowing, due to that they really spent a long time figuring out what's necessary to work with glass. We now consider Venetians some of the best glass makers in the world, and that history really dates back to the Roman time. So one of the amazing projects we had here at the museum was creating a specific commission for these glass airplanes. I do want to show you this video so we can begin to understand how glass blowing really has no limits. What we're seeing now is really a new form of glass art making, but I do want to show you what is possible in the glass realm. So on our top screen now, let's get our glass airplane video.
To fabricate a scale model float plane out of glass takes tremendous effort. Figuring out the exact proportions of the propeller, the length of the body versus the wingspan were all extremely difficult. The Legacy project started off as a collaboration between the Museum of Glass and the Murdoch Charitable Trust. We were commissioned to design and fabricate a glass airplane to commemorate Jack Murdoch. We started by overlaying two contrasting colors of glass that would later show the design elements in the plane. We're working with the glass at a temperature of over 1500 degrees. We create a small color cup to allow for a nice even distribution of color. The colored cup was then stuffed with clear glass to give us enough mass to make the body or the fuselage of the plane. Glass blowing is a team effort. Here at the Museum of Glass, we're unique in that this team has been working together for over 10 years. Each member of our team played a specific role in the creation of the plane. We use a variety of tools to shape and design the body. As you can see here, we're using some cork paddles to rough it out. The body is then transferred to yet another blowpipe so we can finish up the tail of the fuselage. Using those same cork paddles, we give the bottom of the plane a gentle curve before it's put away. After the plane is finished being formed, it's put away into an annealing oven to cool for several days. Once the fuselage was made, we moved on to making the pontoons. We decided we needed to fabricate a steel mold to allow us to make multiples. In order to have the pontoons match the plane, we used the same white color bar. This time, it is solid. The solid glass is then heated up to approximately 2000 degrees Fahrenheit, and then it's pressed into a steel mold. The pontoons are then put into another annealing oven to cool down. In our cold shop, the fuselage of the plane is now being ground or sanded down to remove any unwanted material. We then taped off the plane, and using our sandblaster, we revealed the tail numbers, the windows, and the pinstripes on the fuselage of the plane. The sandblasting process is often very rewarding as the color is quickly revealed, bringing life to the aircraft. After being sandblasted, the planes were then returned to the cold shop to be cleaned up and polished. The wings, the vertical and the horizontal stabilizers were all water jet cut out of handmade sheet glass, again made from the same white color to match the body of the plane. Once the glass parts were finished, we fabricated a small steel structure to hold the pontoons to the body of the plane. The nose cone was turned on a lathe while the propeller was carved out of a sheet of steel to make a fully functional propeller. Now that we have all the parts of our plane, it was brought back to the cold shop where the assembly began. The vertical and horizontal stabilizers were notched out to fit the tail of the plane, while the wing was glued into place. The gluing process takes many hours. We start with 2 clean surfaces, apply the glue, and it sits for over 72 hours before a full cure.
Well, down in the center, the glass makers have done a few different moves by creating a break-off zone, but are now beginning to really shape the massive glass using a few different tools like a wet padded newspaper and really a lot of blown air. This is the actual glass blowing part of glass making. If you're wondering how much air we will blow, we're blowing about the same air pressure you use to blow out a candle, so it's not a lot of air, but it will vary. Sometimes we're asked to blow soft, sometimes we're asked to blow hard. It really depends on how much we're trying to expand the given bubble. Well, we are using a mixture of different torches, both a propane torch, but also a hot torch, which is the hottest piece of equipment on this hot shop floor. Now, this torch is well over 5,000 degrees Fahrenheit, and we're using it to specifically heat up one general area we wish to manipulate next. Now, once again, all the hot glass that we're working with is being pulled out of our furnace we have on the left-hand side of the hot shop floor. And this one is complete. Again, the process does vary. It can take anywhere from 20 minutes to an hour to 3D print some of these designs. This piece will be left to cool down and will be used tomorrow in that demonstration. Again, if you're joining us, welcome to the Museum of Glass. My name is David. I am more than happy to answer any question that you may have about the process you see here today. So on this end of this hot shop, we're stretching out hot glass, and we're using this steel mold down here. Now, what we're creating is this loopy effect on all of our pieces. If we notice that, we're going to try to make that out of glass, but we're going to approach this idea differently. So these loops will be used later on for a sculptural piece. We are now transferring our piece onto a different rod. Now we call this the transfer called the punty. We bring over this new rod. Now Isaac is holding that rod right now, but we create this problem of having two rods. So we will break our previous rod free. We're letting the punty stabilize. We're letting it cool down and creating enough friction essentially to keep everything together. Now that it's cooled enough, we will then add a few droplets of water on the crevice we made earlier, a slight tap, and the piece is broken free. We can now begin to work on that top half of our vessel. Now, since we created a constriction, which is a break-off point, we also thicken the glass towards that tip. So the first step we will take is to thin out the piece itself, pulling it out and getting rid of any excess glass we may have. Now, a great place to view the live glass making, again, besides here, the top balcony, in a cooler environment, is out in our grand hall. We have a lounge area with our live stream set up. It's a great place to kind of relax, watch the live glass making in a more cooler environment. Well, I hope everyone's having a wonderful Monday afternoon here at the Museum of Glass. We do have an incredible event set up for everyone. We are mixing both ceramic and glass together to produce these beautiful vessels. Now, this is the starting point for the next vessel, so if you're wondering how one of these pieces come together, that action will be happening here very shortly. Now, if you have any questions at any given point, again, I'll be roaming around this hot shop floor. We do offer complimentary water, so when you enter, we have some free water. Very important that we all stay hydrated, of course, here. Right when you enter on the right-hand side, so on this side, we will have some free water. It's very important that we all stay hydrated, of course. Again, I'll be roaming around this hot shop floor. If you have any questions, more than happy to answer questions. Now, as we get started with the coloring application process, I do want to let our visitors know that we're going to be having a really quick special demonstration down here on this edge. If you would like to see this, I do recommend it. If we want to like kind of hurdle around this area, I do recommend it's going to be worth it. Other than that, the live glass blowing will continue down here in this center. We have our visiting artists working together to achieve these pieces. We're using a 3D printer, as you see down here on the center of this hot shop. Yeah, this is a great place. This is only going to last like a few minutes, so about 2 minutes, and then we'll go ahead and resume back with the glass blowing action. So once again, the reason why I wanted to bring everyone here is so we can see some of the unique properties of glass as its art form. We always get asked how we make small figurines. We have one of the best pony makers here, so we're going to see Nick really bring this piece together. So this 3D printer right now, we're printing all the pieces you see here that we're going to be using tomorrow, unfortunately, all right? Hello, what's your name? You have a name? My name is David. Musa? Nice to meet you. If you have any questions, you let me know. By the way, for the little ones, if you guys ask me 3 questions, I can give you a little bit of glass, all right? All right? Sounds good? Sounds like a good plan, all right? That's going to be happening later on. So the action will be going back to the center of the hot shop floor now. Yep, I just wanted to show everyone just some of the unique properties. We have our visiting artist down here already gathering some hot molten glass on the end of the rod. The glass is coming out of our furnace about 2100 degrees Fahrenheit, or about the same temperature as molten lava. We are using a pipe cooler, which is cold water. We run on the surface of the rod, which in turn cools it down, making it easier for us to hold and manipulate. And the glass blowing can resume. We are now gathering the necessary amount of glass to make our piece larger and bigger. Again, my name is David. I'll be floating around this hot shop. If you have any questions, please feel free to stop me. So the clay that's down on that end is called flameware. Yeah, no problem, no problem. More than happy to answer any questions you may have. Pretty thin. They're not extremely thick. Well, we added a decorative wrap on the very outside of our vessel. We are now going back and distorting that pattern by rolling back and forth on both on the table and a plate that has a lot of texture that will allow us to really distort and give us that look that we're going for. Yes, you have a question? How do we stay safe? Well, we are all trained professionals. So it's all about communication. Now, I'm sure everyone here on this hot shop floor has probably burned themselves one way or another, but it's really about understanding where you are and where the glass is kept at. So staying safe around those general areas. How long does it take to make our final piece? That's a great question. It really depends on how decorative they are. Our pieces are kind of more on the decorative side with the ceramic added to it. Within an hour, we should be done. So our fuel source here at the museum is natural gas. That is where we are burning to get the adequate heat here at this hot shop floor. Now, the glory hole is where the glass is being reheated, but the glass itself is being pulled out of our furnace. So we have two furnaces here at the museum, one on the right, one on the left. They're both holding approximately 1,000 pounds of molten glass. Behind that door lies a crucible. We are heating that crucible up to about that same temperature as molten lava. So the colors are made by adding different metals to the periodic table. To make like blue and green glass, we can add cobalt. To create green glass, it's specifically iron and rust, essentially. We then can also add like manganese, which creates a purple and black glass. Chromium can produce green also. Uh, and then red and pink glass are made from gold, which make it some of the more expensive glass in the glass industry. Gold to make red and pink glass. Yes, that's why red and pink glass are more expensive, just because you're paying for the gold content. Any pink color? Yeah, let me go bring some for you, all right? Let me go bring some out. I can take that. So it doesn't matter what color we work with, it always looks red and orange. Its true color won't come back till the glass has been completely cooled down. So we won't see that until tomorrow. Why do we have to put it in the oven? Well, if it sticks out here too long, it will actually get too cold and it can break, crack, or even explode. So we place it back in the glory hole to ensure it's staying hot enough that it doesn't break or crack. So what's exactly what we're making is these pieces you see here on this pedestal. Precisely this one, they're going to be a little larger, a little different shape. So I did bring out some two specific colors. I brought this beautiful red, which is some of that red that they use, pink, that they use gold. I'm going to pass this off directly to the back, all right? So we got to be a little bit more careful with this color. I also have another bar, this green glass. You got to be a little careful with this bar. Again, we want to make sure we don't break it. So this other bar we have here is called an adventuring green. This is made from a rare ore. This stuff is extremely expensive. I don't even know how the museum gets it. This is always sold out every time I try to purchase it. It's incredibly, it looks like a sparkle, like a green sparkle glass. Again, it's made from a rare ore. A rare ore. I don't remember exactly. I think it was like mica, which is a very rare ore found on Earth. There's like very little of it, and I know they're producing glass color off of it. Again, every time I try to purchase this, it's always sold out. They only make that in red, or I'm sorry, green, blue, and gold. Yes, everything, I would say, yeah. Even if we dropped it, I think it would be a little bit more harder. But yeah, that green one is like my favorite color ever. Again, these bars are some of the more expensive ones, so these ones are hand-rolled. So the company doesn't mass produce these. They will hand-roll these. Yeah, anytime. Yes. So the bar you're looking at, typically when we start off, this bar can cost us like $20, $30. The bar that we're passing around right now can be upwards of 100. It can make as many pieces as you want. It can make maybe one piece or make several pieces. It's up to you how dense that color should be. It could be quite light, but it's going to be more of a transparent color, so it depends. The color does start off like this. So I'm going to show you a quick video here on our top screen to show you exactly how the color is applied. So on our top screen now, let's get our color overlay video. Now that's going to be happening very shortly here.
The color in glass comes from adding various materials to the mixture of raw ingredients called batch. Most of the colorants are compounds containing some kind of metal. For example, adding cobalt to clear glass creates a deep blue. Tin and antimony can be used to create white glass, and gold chloride can produce a rich red or pink colored glass. Colored glass is melted in furnaces, just like clear glass, and then is usually rolled into bars for storage and easy application. In order to apply color bar to a bubble, we first need to preheat the color to approximately 950 or 1000 degrees Fahrenheit in a color oven or garage. Once warm, the color is then picked up on the end of a punty rod using a little bit of clear glass as a support. The color is then heated in the 2300 degree glory hole to soften it and make it malleable, while another artist creates a small bubble of clear glass on a blowpipe. Once warm, the color is dropped over the clear bubble, and then using a variety of hand tools or the steel marver, the color is rolled back over the clear in an even layer. This process is called dropping color, or creating a color overlay. Depending on the project, that bubble is then usually gathered over with clear glass and blown into the final form. The finished product may appear to be all made from colored glass, but when viewed in cross-section, we can see that there is only a thin layer of color sandwiched between many layers of clear glass.
So there's a couple different ways. For our vessel ourselves, it's a lot more different than like this pony that we make. As we go through this process, I'll explain some of the key details that's going on here. But essentially for our vessel, there's a small waste point. We have a break-off zone that we've already created. We're going to use a few droplets of water water is extremely bad to hot glass, but we can use that to our advantage. You've asked me 3 questions now. That's good. I have some glass to give you, but you also here, you asked me 3 questions, so if you guys want to meet me down here, I can give you guys some glass, okay? Oh yeah, you're more than welcome to check out the rest of the museum. I highly recommend it. We have some beautiful pieces handmade here at the museum. So I do want to spend a second and talk about Phirak down here. He's the person, really, the mastermind behind all this that you see in really a lot of this residency. Phirak has dedicated well over 8 years to kind of figuring this out. He's like a pioneer to what we're seeing right now. Before him, there's only been one other artist I see do something similar, and 90% of what we made broke. It was just the clay wasn't compatible with the glass we have here. But Phirak's done so much research. He's found out the clay that will work with our glass. And it's just unbelievable that Phirak has taught classes very similar to what we're seeing here all around, including Pilchuck Glass School. Like I said, he's a pioneer, essentially what you're seeing here today. Everything that we're using, he is designing both in Grasshopper and Rhino. Oh, yeah. So he's just an incredible, talented artist that's doing a lot of behind the scene work that we typically don't see. We have our second visiting artist sitting down here in the center. Now he's getting his hands dirty using all these molds, but really it's Phirak that has a lot of this stuff being made, and it's really because of his help that we're able to do what we see here today. So Chihuly is a very proud sponsor of this museum. He's a founder of this museum. However, Dale has his own studio in Seattle where he stays. He keeps his work there. Yeah. Typically, it would be a very special event that we will host if Dale ever comes to the museum again. Typically, Dale doesn't come to this museum anymore, really because he doesn't want to take away any credibility or any for the artists that we have here. Dale's a very believer that it's now time for the next generation. That's what we really enjoy about Dale a lot. He's ready to pass on the torch to the next artist, and that's one reason why Dale really doesn't come here to this museum. He feels that he would take too much attention. Dale's an extremely humble person, and it's really why he decided to kind of step away from the museum. I meet Dale about 2 times a year. He's an incredible person. Do we have a video of him making glass? We have some like DVDs out in our store. We also have a video out in our gallery. Let me talk to AV. Let's see if we can pull up anything on our archives here, okay? There's a chance, but I don't want to get our hopes up. Let me get a hold of our AV crew and let's see what we can do. Just like that, our piece is complete. The next step is to slowly cool it down for the next several hours. If we leave the glass out here, it'll get too cold too fast. It can break, crack, and even explode. So these pieces are all ceramic. They're a specific ceramic, however. They're all made from flameware, which should be resistant to the heat. Again, it should be. We won't really know if everything's successful until tomorrow when we open the annealer and inspect all the work. I'm sure there's some gonna crack. Some of them will break, but we're hoping that the numbers will have good success rate.